Okay, so another thing we would want to consider when we're talking about length-tension relationship, angle of fibers, position of joints, then we look over at this force-velocity curve, right? And these two curves are interrelated to one another. If we can understand the position of the joint, the position of the fibers, and what's happening, are we getting a lot of active tension? Are we getting a lot of passive tension? Or a little bit of both, right? Then we start looking at speed. So are we looking at an eccentric, a very, very fast eccentric contraction, or a very, very fast concentric contraction, or an isometric contraction, right? And then if we know the contribution of the different types of elements in the muscle. So if we're a very, very fast eccentric contraction, we know we must be on this side of the length-tension relationship. So we are getting, if we're a very, very fast eccentric contribution, very, very fast eccentric contraction, right? Then we know that the fibers must be oriented at a pretty steep angle or very small angle. The joint is opening very quickly, right? So we're going into like the down phase of a pull-up, or our body's moving down away from the bar. And so we have sarcomeres that are trying to move inward. We're making cross bridges, not as many as we definitely could up here, but we are making cross bridges, and we're developing a ton of passive tension with that PEC. Let's go ahead and write PECSEC here. And then, of course, if we look over here, if we're doing a super fast eccentric contraction and we've got maximal contribution, total tension is developed here, we're going to get a ton of tension developed eccentrically. That tug of war with the cross bridges is being played, and a ton of passive tension. So that's why we can make lots and lots of tension eccentrically, tons of force. And then if we move down to the concentric side, you see if we're going concentrically, we must be moving more into active contribution, with myosin and actin being the primary, the cross bridges really being the primary developer of force here. We still have some passive contribution, yes, but they're becoming more, the active is becoming more of the contributor of force. So we, no matter what, will never be able to make as much force concentrically as we can eccentrically because of this passive tension development contribution over here. All right, so hopefully that makes sense. If we're doing super, super fast concentric contraction, obviously we're relying on very, very fast sarcomere contraction. You note that timing as far as sarcomere contraction goes and myosin head activity, myosin head ATPase, it depends on what type of fiber we're talking about. Are these type 2s or these type 1s? But a lot of it's active anyway. It's myosin and actin interacting to make cross bridges. So if we're really relying on the active force contribution here for a very fast concentric contraction, then we can develop a ton of force, but not as much as we'll be able to eccentrically because of everything contributing from over on the right-hand side of the curve. Hopefully that helps. Happy studying.